grade. Welcome to week 8. Today is May 11th and it is day 1 of week 8. So this week we're going to focus on just the elimination method. We're going to wrap it up by reviewing today what you have to do if you need to multiply both equations by a constant. And then once we go over that, then you will have learned everything there is to know about elimination, and we'll just do some practice problems where you should be able to look at the problem and understand what which elimination strategy you should use, whether you're going to add, subtract, or multiply. You can expect at the end of the week to be taking an evidence on elimination on Friday. There's an agenda right here that kind of walks you through what you'll be doing or expecting to do each day. So please check that out as well, just so that you have a good idea of what the week has in store. Okay, so you'll see we now have week 8, day 1, May 11th. There is a lesson here. When you click on it, there's 2 links for support if needed. This link is the same teacher guide that I've been using for a few of the other support links. And then this one is a female teacher, but she kind of takes you through a few different examples. So if you wanted to fast forward to 12:10, she does a modeled example of what we're focusing on today. Okay, so here's our lesson. I'm going to use the bigger version over here. Okay, so we have for our warm-up an elimination with multiplication problem again. In this example, we are going to multiply the top equation. I normally like to multiply by a constant that is its opposite. So you'll see on the following slide that I decided to eliminate y. So I multiplied by a positive 2, since the y of the second equation was negative 2. And by multiplying by 2 for every term, we got the new equation 2x plus 2y equals negative 18. And then when we add them, because our y's are opposites, they will eliminate to 0, allowing us to find our x value. And then once we have x, we substitute into one of the equations and solve for y, and then we write our solution, which would be 2, negative 11. Okay? So you guys did pretty good with that. I was noticing that on your work, you were understanding the concept, and most of the time it was just like minor calculation errors or transcription errors, where if you were copying it from maybe the computer to your paper, you were leaving off a negative, but the concept was there for those of you that did submit your work. Okay, so I was happy to see that. So what we're focusing on today is still elimination with multiplication, but in systems where you're going to have to multiply both of the equations by a constant because they don't have a common factor where you could just multiply one of them. All right? So when given problems like this, you're going to look at the system and you are going to decide on a variable to eliminate. Okay, and then you're going to multiply both equations by the other equation's coefficient. Now that sounds a little strange, and my hint at the bottom is to make it easier. Make sure that when you do multiply, you make it so that they are opposites. So that one, you may need to make negatives so that you get opposites out of their product. Because like I said, it's so much easier to eliminate by addition rather than subtraction. So just keep that in mind when you're picking these constants. So I wrote the same system on my board to take you through it. And notice, we can't multiply just one of them to get a product to match the other coefficient. So we have to multiply both of them. So I'm going to choose to eliminate x. So I'm going to put my parentheses around both of the equations. And then what I do is I take my coefficient of this x, and I'm going to multiply it by the top equation. I take the coefficient of this x, and I multiply it by the bottom equation, and then I make one of them its opposite so that the products come out opposite so that I can add. So I'm going to make the 5 a negative 5. So we take this equation's coefficient of x and we bring it down to here. That's what we're going to multiply by this one. And then we take this equation, the second equation's coefficient, multiply it by the top, and then we make sure that one of them produces opposite products so that we can use addition with elimination. Okay, and now all you have to do is distribute. You have to distribute twice. So we're going to do negative 5 times 3x. We'll get negative 15x. Negative 5 times positive 3y. Negative 15y. Okay, negative 5 times negative 27 will give us a negative times a negative is a positive. So we would get positive 135. All right, so that's our top equation. And now I'm going to do the bottom equation. So 3 times 5x gives us 15x. And notice our x's are now opposites, right? 3 times negative 2y, positive and a negative, give us a negative 6y. And then we have our last product, 3 times 32, and that's going to give us 96. Okay, so we multiplied both equations by a constant. We made sure that one of them made it opposite products, so that now, looking at this, we can eliminate using addition. And now everything stays the same like you guys already know how to do. So I'm going to make my vertical lines down, and we solve through addition. So negative 15x, I'll write it here, plus 15x gives us that 0, which eliminates the x's, okay? Then here, negative 15y plus negative 6y, same signs, we add and keep, so that would give us a negative 21y. And then we do our equals, our constants, 135 plus 96, bring down our equal sign, 135 plus 96 is going to give us 231. Okay, so then we should know at this point we like to rewrite it without the 0 there. So I'm just going to write that over here. So negative 21y equals 231. To get y by itself, we'll divide by negative 21 on both sides. These will cancel. So we'll be left with the quotient 231 divided by negative 21 equals negative 11. Okay, and then once we have what y is, we pick one of our equations. We have a choice of 4. We could pick either the original top, the original bottom, or our new top and our new bottom. So I think I picked this one for some reason in the lesson. So that's the one I'll use again. So I'm picking this equation. Okay, I'm going to rewrite it over here. So we have oops, I'm not in the screen. 15x minus 6y equals 96. Okay, and then I'm going to rewrite it. So 15x minus 6 times y was negative 11, so negative 11, okay, equals 96. And now we just solve for x. So let's see, I got 15x. Then this is negative 6 times negative 11. Be careful with these signs, guys. I'm seeing a few mistakes happening here. You're forgetting that this is a negative and this is a negative, so their product is positive 66 equals 96. And then we would subtract 66 from both sides. We'll get 15x equals 30. And then we divide by 15. And we'll get a final answer of x equals 2. So then the only thing we have left to do is to write our solution. I'm going to just write it at the top since I have space. So solution. And we want our x to come first, so it would be 2, comma, negative 11. Okay? So everything that we just went through, you guys have seen. This was the only new part of it, that multiplication in the beginning. So just know that you're going to be multiplying both of the equations, and normally I just flip-flop the coefficients. That's how I decide what to multiply by. Could you multiply by other numbers? Absolutely. This is just like an easy trick where you'll always get the same number if you just flip-flop the coefficients, okay? And then just keep in mind, if you make one of them so that the products come out opposite, sometimes you might need to make one negative, then you can use the addition method for elimination, which I think makes things a lot easier because then you don't need to remember to keep change, right? So everything that I just showed you is in the lesson. There's the solution we came up with as well. And then there's your steps, okay? So you're going to pick your variable to eliminate. You're going to multiply both equations by the other's coefficient. Then you rewrite the system after you distribute. You look to see if you have same or opposite, which most of the time you should have opposite because, like I said, it makes it easier to use addition to eliminate. And then you just follow the same steps that you guys have been doing already. So I'm not going to repeat myself, okay? So here's another question. I'll model one more for you, and then I'm just going to show you the few at the end that are like special cases. I want to make sure you understand what happens in those situations. Okay. All right. So I believe in this example, I decide to eliminate y this time. Yes. Okay. You could eliminate x, right? But I'm just going to model it so that you can see that you can also eliminate y. So again, I'm going to make my parentheses. Okay. Now notice I have opposite signs already. So I'm going to keep my coefficients positive so that they stay opposite each other. So I'm going to take this 4 and multiply it by my top equation. And then I'm going to take the 3 and multiply it by my bottom equation. Because I know that 4 times 3 will give me 12. And then 3 times negative 4 will give me negative 12. So then those will eliminate once I'm done multiplying. All right, so let's multiply now. So I'll just do this real quick. All right, so that's going to be our top equation. So we would get 8x plus 12y equals 56. And then we would distribute our bottom equation. Okay, and we would get 9x minus 12y equals 12. And now that it's set up, we can use our addition elimination method. Put my lines. Okay, so we do 8x plus 9x. 8x plus 9x equals 17x. Okay, 12y plus negative 12y gives us that 0, so our y's eliminate. 56 plus 12 gives us 68. Yep, so bring down the equal sign, 68. And then we just rewrite it without that 0. So we have 17x equals 68. Divide by 17 on both sides. And we'll get a final answer of x equals 4. Okay? So again, we chose to multiply by flip-flopping the coefficients. We made sure that the products would come out opposite each other so that we can use addition to eliminate. We solve for x. We're going to pick one of the equations to solve for y. So this time I picked this one right here. 8x plus 12y equals 56. So 8x plus 12y equals 56. And I will rewrite it. So now we would have 8 times x is 4. Okay, plus 12y equals 56. 8 times 4 is 32. Plus 12y equals 56. We would subtract our constant of 32, so minus 32 to both sides. Cancels over here. I'm left with 12y equals 24. Divide by 12. So y equals 2. So our solution, our final answer will be 4, 2. And I'll put it up top again because I seem to keep leaving space up there. Okay? So again, you see the multiplication, solve for one of your variables, move on so that you solve for the other, and then write your final solution. Everything I just modeled is in the lesson as well, so if I went too fast at any point, everything is there with the steps provided on the right side to go along with it, okay? So there's a few more for you to try, and then these two are the ones I wanted to focus on just before I wrap it up with you. Let me just erase my board so that I can really show you what happens here. All right, so these are two special cases because you would solve by multiplying like I just showed you, but something interesting happens when you do so. So we'll look at the first one first. So in this case, I actually don't need to multiply both equations because I'm noticing if I multiply the top equation by 2 or even negative 2 so that my x's are opposites, I don't need to do the second equation because they will already be opposite. So I'm going to do that. I'm going to take this one and multiply it by negative 2, right? So this is kind of like what we did on Friday. So let's see. Negative 2x times 2x will give us negative 4x. Negative 2 times negative y will give us a positive 2y. And then negative 2 times negative 1 gives us a positive 2. Okay, I'm going to rewrite the second equation because I don't need to do anything to it. So we'll get 4x minus 2y equals 4. And now I already know I can solve through addition because my x's are opposite, right? So I'll make my lines. So negative 4x plus 4x will eliminate. We'll get 0. Okay? 2y plus negative 2y also eliminates. So we get another 0 equals 2 plus 4 gives us 6. If I simplify the left side, 0 plus 0, I get 0 equals 6. And what do we know is true when we get a false statement? When we get a false statement, this means there are no solutions. If you were to graph this system, if it was in slope-intercept form, these would be parallel lines. So if you're solving and you wind up getting a false statement where your variables cancel out and it equals to a number, that's not 0. That means there's no solution. These lines are parallel. They will never intersect. There would be no solution. Okay? So that's one. And then the other possible thing that could happen, I'm going to rewrite the system for number 2. Okay, so similar to, I feel like those are too close. Let me make that. Okay, similar to the one we just did, I only need to multiply the top one. I can multiply it by 2 to get my x's opposite again, right? Because this would give me a 6 and a negative 6. So let's do that. Okay, so let's see. So 2 times positive 3x is 6x. 2 times negative 2y is negative 4y. And 2 times 6 is 12. Okay, I'm going to rewrite the second equation since I didn't do anything to it. Negative 6x plus 4y equals negative 12. And like I said before, I know we're going to add because my x's are opposites. So I'll make my lines down. So 6x plus negative 6x is 0. Eliminate. Negative 4y plus 4y also eliminates. So again, plus 0. Bring down the equals. And then 12 plus negative 12 is 0. So when I simplify, I'm getting 0 equals 0, which this time is a true statement. So how many solutions do you think there are if our variable eliminated, and I'm getting a true statement, this would be infinitely many. Okay, these two lines would be exactly the same, so they would share infinitely many solutions. All right, so these are like the two tricksters that come up. I just wanted to make sure you saw them. The work for them are also provided in the lesson. I just didn't want you to get confused if they turn up. I don't think that they will be on your assignment today, your exit ticket, but they do come up later in the week. So I just wanted you to get a heads up on that. All right, so then once you're done, you'll go and complete your Google form. There are the 4 questions that you're responsible to. Oh, I didn't attach it. All right, I'm going to attach it. So there'll be a Google form for you to complete, and then there'll also be a Google Doc where you will show your work. I don't know why the attachments aren't showing up here, but they will be there. So make sure, oh, here it is. So here's your work. Same as usual. You'll show your work in the space by either doing it digitally or sending it to me through one of your options of Instagram, email, text, Pupil Path, whatever works best for you. And then also you will submit the Google form as well. I just want to reiterate, it is not one or the other. You are responsible to do both. The Google form is just for you to put your answer in. The Google Doc is for you to show your work. Okay? All right, 8th grade, take care. Hope this helped. Stay safe.